is a library that extends the capability of Python to add richer data sets, include more numeric type, particularly vectors, matrices, and many matrix functions. NumPy and Python work together fairly seamlessly. पाइथन अर्थमेटिक ऑपरेटर्स जो पाइथन के जो ऑपरेटर्स हैं प्लस माइनस मल्टीप्लिकेशन डिवीजन रिमाइंडर कैन वर्क ऑन numpy data types जो numpy की data types and many numpy function will operate directly on Python data types. So first of all, most important thing to understand is vectors, matrices. So vectors, you will see them in this course, are ordered arrays of numbers. अब Python में arrays exist नहीं करते. There are no arrays in Python. Okay? So that's why we are using NumPy. Vectors are ordered array of numbers. In addition, and notation vectors are denoted with lowercase bold letters such as X. The elements of vectors are all these. For example, if this is a vector, then all of these elements are of same data type. Same data type. A vector does not, for example, contain both characters and numbers, just like list. Number of elements are often referred to as dimension. Okay, for example, for this vector we have dimension. It has a dimension of n, and in mathematics we call it as rank. They are interchangeable. Though mathematician may prefer rank, the vector has a dimension of n. For example, this one, it has a dimension of n. The elements of a vector can be referenced with index. We have indexes. In math, indexes normally start from 1 to n, but in computer science, we start, in Python actually, we index from 0 to n minus 1. So we can refer it with respect to xi, or the zeroth x0 for the zeroth element. In particular, for the NumPy arrays, NumPy basic data structure is indexable n-dimensional array containing elements of the same type. What is the type of NumPy array? D type. Right away, you notice we have overload. Now, above it has the number of elements in the vector. Here, the dimensions refer to the number of indexes of an array. Dimension का word, we use it. Previously, we used it for the number of elements. Number of elements in an array. But over here, the word dimension is overloaded. Means it has more than one name, more than one definition. Dimension, more than one definition. So over here, dimension means number of elements, or in pure mathematics we call it as rank. Like number of elements in an array is often referred to as dimension, though mathematician may prefer the word rank. But in NumPy, we have 1D, one-dimensional array. 2D array means this is a vector, it's a matrix. So 1D array means like this. Over here, it means the dimension means it's an array of elements or a vector or array of elements. But we also have in NumPy 2D, means we have a matrix. So this is the difference between now the word dimension is overloaded. Above it was the number of elements in a vector. Here the dimension refers to the number of indexes of an array. If it has only one index, just like this 0, 1, 2, 3, 4, this array has only one index. So we call it as vector and we represent it as 1D because it has only one index. But in the case of a matrix 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So now we have two indexes to represent one element in a matrix. So that's why we call it as 2D dimension, because it has two indexes. So do not confuse the word dimension. In dimension means number of elements also, and in NumPy dimension means number of indexes. Means it's a 1D array or it's a 2D array or a 3D array. So that's why बेटा 1D array ये हमारा array है simple. इसके indexes क्या है? What are its indexes? 0, 1, 2, 3, 4. So we call it as 1D. But how we will? But when we have a matrix, A11, A12, A13, A21, A22, A33, A31, A32, A33. So now we have two indexes. So in NumPy we call it as 2D because now we are representing this matrix with the help with two indexes. Now the array will have two indexes. So that's why a one dimension 1D array has one index, and we will represent vectors and NumPy in 1D arrays. 1D array shape n is the number of indexes. Number of indexed 0 through n minus 1. Shape ये method. This is a method. Shape n. How clear हो जाएगा? How to create vectors using NumPy? Data creation routines in NumPy will generally have the first parameter, which is the shape of the object. This can either be a single value 1D or a tuple, means we can also pass a tuple, specifying the shape of the result. Below are the example of creating vectors using these routines. NumPy routines which allocate memory and fill the array with some value. For example, np.0 4, np.0 4, np.random sample 4. So let me run it first. So now let's see. np.0 हमने यहाँ पे मेथड कॉल किया .0 4 उसका इंडेक्स 4 हमने उसमें पैरामीटर भी पास पैरामीटर 4 so it has created an array with 4 elements. It has 4 elements. np array. If we And this method, a dot shape, it will return the number of elements, and a dot d type, because actually this is when we created this a vector, actually it's an object. ये क्या है? Object. Now with the help of dot operator, we can call its methods. So we np.0 np.0 will create an a vector of 40 elements, and we label it with a. Once created, now when we can call its call different its built-in methods: a dot shape, a dot d type. So it's a float 64. It's a float. Same is with the next example. A assigns np04, and there is a comma over here. Again we have same output. There is no difference. You can create it with the help of this routine or with the help of this routine. And another one, random np.random sample 4. So it created random values, and its shape is again 4, and data type is float 64. Data type is same, but over here we call its random method, random sample of 4 times random values. So in this way we can create vectors using NumPy. So over here, NumPy routines which allocate memory and fill arrays with values but do not accept shape as input argument. Do not accept shape as an input argument. np.arrange 4 dot, so it 0 1 2 3 np.arrange, n shape again 4 type data float, np.random.rand method, we call it as rand method 4, so it created 4 elements. Shape again 4 comma, it's only one, and data type is float 64. So this is another. So these are another routine to create a vectors using NumPy. So over here we are creating. So it yes. So for zeros, it create a vector of 4 elements with 0 values. We can give values. We can give values numerically. np array, np dot array method, because this is a method, and over here you have a list of elements 5 4 3, and again you can call it a shape method over here, and a dot d type to return its typ, to return its data type. So again we have an array 5 4 3 2 1. Shape again it's a single index element, because it's a single index. Otherwise if it's a matrix, then we have 2 over here. So 4 elements with single index, and its type is int 64, because these are integers. Over here we same another example, but we put a dot with point, we put a point with 5. So it's same like Python, its type changed from int to float. So its type is changed. So this is the difference. Over here we have 5. So its type is int64. But over here we have 5 point. So its type is float64. Since it's an array of single index, and this 4 represents that vector A is only single index. Vector A is a single indexed array with 4 elements. It means that single indexed array with 4 elements. These all have created one dimensional vector A with 4 elements. A dot shape returns the dimension. Here we see A dot shape 4 indicating 1D array. Indicating 1D array with 4 elements. So this is these are different ways in which we can create a vector using NumPy. These are different ways. You can specify the exact values and number of elements by using parentheses and square brackets. 5, 4, 3, 2. So this is one way. You can use arrange method. You can use random method. You can create an array np zeros, np.0, specify the number, specify the element. Over here we are specifying the total number of elements and indexes. It has one index, and that one index is this one. And that one index is taking 4 elements. One index with 4 elements. So this is how we create vectors using NumPy. Important thing is that these have all created one dimensional vector. This is one dimension because the shape method is returning only one dimension with total number of elements and return. And here we can see that the shape method will return the number of indexes and total number of index in one, total number of elements in one index. Total number of elements in one index. Now, so these are now we have created the vectors. Now operation on vectors. Let's explore some operation using these vectors. Elements of the vectors can be expressed by indexing and slicing. We already studied slicing in in Python with colon operator. NumPy provides a very complete set of indexing and slicing capabilities. We will explore only the basics needed for the course here. Reference for more details. Slicing and indexing. Indexing means referring to an element of an array by its position within the array. Slicing means getting a subset of elements from an array based on their indexes. NumPy start index at 0, so the third element is represented by a2 because index always start in Python with 0. Now, let's see some of the operations. np.arrange with 10 as a parameter. So it will create an array because the word is arrange. It will create an array of 9 elements. One dimensional array 1, 0, 1, 2 up to 9. Just like here, 0, 1, 2, 3 up to 9. 1D array with total number of elements equal to 10. Total number of elements equal to 10.
Okay.
In order to access an element, so our A at index 2, at index 2, 0, index 0, 1, 2, index 2. So we have 2 at this place. 2 at this place. So we index. So over here we rotate like this. A at index 2. Accessing an element, it will return a scalar. It will return a scalar value. So this is the print statement. We have this is F stands for formatting. We studied during the Python. F stands for formatted string. Formatted string. So we are formatting this string. So a dot shape will be printed as it is. You see, a dot shape will print up to comma as it is. Then a second index dot shape. So it will be empty. Again, a index 2 will be printed as it is, equal. Anything we will put in curly braces, it will give this will give the value, and the difference between here and here is that we do not put these curly braces over here. So over here we will get the value. This is a formatted string. Over here, this A2 will not give the value. It will be printed as it is. And so this, and over here, there is no, we do not have this one over here. So this one and this one will be printed as it is. This one and this one will be printed as it is. And third element, index 0, 1, 2. At third element, accessing an element returns a scalar, so it will give us the value to accessing it will return a scalar. It will be printed as it is because this is double quote and it's a formatted string. Anything between the curly braces will give the value. Otherwise, it will be printed as it is. So these are tuples in Python. We already discussed tuples in Python. So this is a tuple, and they are also ordered index 0, index 1. It has a length function. If I change over here, print this tuple, It will print the tuple. If I give its index 0, it will give apple. If I give 3, so it will give a tuple index out of range. So why I need to explain it over here. So a dot shape over here is returning us a tuple. Is returning us a tuple. It's returning us a tuple. So when we access to access the last element, we can use the negative indexes. So a assigns -1. It will give us the last element, and the last element is 9. And last element is 9. Now again you can see it will be printed as it is because it's a formatted string, but this is in the curly braces. It will give us like indexes must be within the range of the vector. There will be provide an error. For example, AC is 10 exception error message. You will see this. We are accessing the 10th index. The total number of elements are 9. We have only 9 indexes, but we are extending, so it will give us an error. When we read error message, you will see is index 10 is out of bound for access 0 with size 10. So this is okay. Now slicing. Slicing creates an array of indexes using set of the values. There are 3 parameters: start, stop, and step. This slicing we already discussed in strings, in strings and in tuples and in list. We already discussed. I will repeat again. A subset of the value is also valid. Its use is best to explain by example. We have created an array of 10 elements. So print A, so it will give us the whole array. इसने हमें क्या return कर दिया? It printed an array for us. Access 5 consecutive elements. We need to access 5 consecutive elements, starting from index 2 to 7 with 1 increment. 2, 3, 4, 5, 6, 7. 2 to 7. 2 colon 7. It means element at index 2, element 3, 4, 5, 6. 1, 2, 3, 4, 5. For 7, why it becomes 6? Because we normally take n minus 1. Last index is not counted. We need to make it n minus 1. So that's why we have 5 consecutive elements starting from 2 to 6. Starting from 2 to 6. We passed 2 to 6. We passed 2 colon 7 and step size is 1. Step size is 1. Access 3 elements separated by 2. 2 to 7 and step size is 2. Again, you can see the print statement. We call print method, and in print method we have double. In the anything in the double com will be printed as it is, and we are printing this one. See, access all element index 3 and above. 3 and above. 3 colon. So it will from 3 to the end element. Access elements below index below index 3, not including 3. So colon 3. It will give us 0, 1, 2. Print all elements. Again, just type separated by 2. We have 2, 3, 4, 5, 6. So we have separated by 2. Over here It means 2. We will draw. We will separate it by 2. This one we drop this one and we get this 2, then 4 and then 6 separated by 2. Step size is 2. Over here when we have one step size 1, 2, 3, 4, it means that this is step 1. We write 2, 3, 4, 5, 6, S1, S2, S3, S4, S5. So separated by 2 steps means if we print 2, then over here is we can skip only one step, then it becomes 3. Step. We skip this one, we will print 4, or you can consider it as n minus 1. Step 1 means every element. Step 2 means you will drop one element. Step 3 means you will drop 2 elements. कि आप 2 elements drop करेंगे. Step 1 means in step 1 you can see 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, good. But when we have step 2, so we skip 1. We skip. We take 2, skip 4, we take 4, skip 5, we take 6. So that's why we have 2, 4, 6. So this is slicing. So this is indexing, how we can index vectors using NumPy. So it's simple. We can use just square brackets for this one. And for slicing we have colon, and it has 3 parameters: start, stop, and step. Start, stop, and step. Three parameters. And these are and all these 3 are optional. ये तीनों क्या है? Optional है. For example, over here we did not specify any start, stop, and step. So these are optional. ठीक है, यहाँ पे there is no start, stop, and step, but over here we have start, stop, and step. And another thing is that for the last index, just like it's 3, it means it's n minus 1. We have 3 minus 1, it means 2. We will go from 0, 1, 2. 0, 1, 2. So this is slicing. Now, single vector operation. We have created an array by giving it a value, numpy array parenthesis, और यहाँ पे we give them the values 1, 2, 3, 4. So when we print it, A assigns A colon, print it gives us 1, 2, 3. Minus A, minus will be multiplied inside this one. B assigns minus A, and we are printing B. So minus 1, minus 2, minus 3, minus 4. NP has sum method. NP dot sum A 1, 3, 6, 10. So NP dot sum A, it will sum all the elements in the given vector and it will give 10. ये मैं क्या रिटर्न कर देगा? 10. Sum method. It will sum all. NP dot sum, NP dot mean, it will give the average of the array, of the vector can base. It's better to call it as vector, average of the vector. How we the power operator in Python is like this. Means 2 2. It means 2 raised to power 2, it becomes 4. So over here, A 2. A is a vector and we are making it square. So it will element wise it will perform power operation element wise. So 1 square, 2 square means 4, 3 square means 9, and 4 square means 16. So we have this 1, 4, 9, and 16. So this is single vector operation, means you are multiplying a scalar value with a vector. Now vector operations, vector element wise operation, vector element. For example, if A is a vector, A vector plus B vector plus B vector. Now the addition will be performed element by element. NP dot array, we have created one vector, we have created another vector A plus B. So it will give us, we add them 0, 4, 6, 8. It's minus 2. It means 0, 0, 6, 4. 6, 8. 0, 0, 6, 8. It's element wise operations. In order to do element wise operation, the size of the two vectors must be size of the vector must be same. Size of the vector must be same. If we have and this is try and accept. We already studied in this when we started the Python at that time. Try accept block. If there's an error, if there's no error, it will run the try. But if there's an if there's an error in the try block, it will run the expect block. Except block. So we have created an array of two elements, and in D, A is this one, and C is only of two elements, and we want to A plus C. Now size of A is 4, size of C is 2, so it's not possible. We will get an error over here, but due to try and accept block, program will not stop here. Once it get an error in try block, it will execute the accept block, exception as E, print the error. You will see this E. So over here, operands could not be broadcast together with shape 4. So this shape 4 means 1D array with 4 elements. This means 1D array but 2 elements. So exception as E, the error the error that came in try block is saved in E. So that, and we print E over here. So this, it will work like this. Try and accept block. First thing, because we wrote this code in try and accept block, so when we get an error in try block, it will execute the accept block. जी बेटा, आई विल रिपीट. कोई इशू हो बता दिया करें, आई विल रिपीट इट, नो प्रॉब्लम. क्योंकि अब ये इस वीक में हमने वी हैव टू कंप्लीट ऑल दीज 4 Jupyter notebooks. So NP array, it will give us error, and because of this error, program will not stop because we wrote this code in try and except block. So this except block will be executed, but in except we write this line exception. The error which came over here, the error which came here will be is stored in this exception as E, and afterwards we print that A. So that's why we got this line, and in this line we catch that exception, and we can see our error. Otherwise it's very difficult. Program will stop over here if we do not have this. For example, let me check this one. Okay, यहाँ पे कोई error तो नहीं है. Okay, it will execute successfully, and it gave us an error. I will add a cell over here. I copied it as it is in this block, and I removed the except block. Now you can see the difference. So over here, the program stop over here, and that error, this line, we catch this line as an exception, and we pass it to as E, and later we print this E. Okay, beta? So this is what. Now scalar vector operations. Scalar vector operations. Vectors can be scaled by scalar values. Scalar value is just a number. The scalar multiplication, all the elements of the vector. So we have an array 5 static A. Now it will perform element wise multiplication 5, 10, 15, 20. We get this. Now, vector operations. For element-wise operations, we have this dot operator. We also studied in the lecture dot operator. So what is this operator? The dot operator is a ministry of linear algebra and NumPy. This is an operation used extensively in this course and should be understood. The dot product is shown below. Now, so what is the dot product? A dot B sigma 0 to n minus 1 ai bi. So A dot B, actually we have two vectors, this one and this one. We are multiplying them. So A0 B0 plus A1 B1 plus A2 B2 plus A3 B3, and dot product multiplies the values in two vectors element wise, and then sum the result because of this sigma. First it multiply the two vectors element wise and then sum them. The dot product multiplies the values in two vectors element wise and then sum the result. Vector dot product requires the dimension of the two vectors need to be the same. Both the vectors should have the same dimension. Let's implement our own version of the dot product, because using a for loop we can also, if we do not take the, just like in lecture we have discussed that either we can do, if we are considering the vectorization concept, we can do directly the dot product. Otherwise we have otherwise in order to multiply the two vectors we will going to use the for loop. So over here we define a function with def keyword. Name of the function is my dot, and we are passing two vectors and we are passing two parameters. Compute the dot product of two vectors. Arguments, array input vector with same dimension as a. So nd array. Returns, it will return a scalar value. So for x assigned 0, we define this method x assigned 0 I in range a dot shape index 0. So shape method will return a tuple. ये shape method क्या return करता है? Tuple return करता है. Tuple में क्या होगा? If it's a one dimension array, for example, if our array is 1, 2, 3, so it will return 3 over here. This 3 represent two things. Number one, total number of elements in the vector. Second thing क्या represent कर रहे? Because there is only one over, there is no index over here, no, nothing is here. So we have only one element over here, and its value is 3. 3 represents the total elements in a vector, and since this is only one value over here, it represents that it's a 1D array. So over here we call a dot shape and pick the value at index 0. So if we have 3 elements array 1, 2, 3, so shape method will give us 3 comma, so this is a tuple at index 0. What value we have at index 0? At index 0 we have 3. So when we pass 3 in the range method, it will give us a list 0, 1, 2. So that's why over here, if our a size, if our elements in the vector are 3, it gives us this list 0, 1, 2. So in I we have, in the first iteration we have 0, in the second iteration we have 1, and the third. And over here we are multiplying both elements, and just like calculating the average, sum assign 0, we assign x factorization approach. ठीक है, ये क्या है? ये एक नॉन वेक्टराइजेशन अप्रोच है. ये हमने लेक्चर के अंदर वैसे बहुत डिटेल के साथ डिस्कस किया हुआ. ये मुझे वैसे क्विकली, आई हैव टू पास इट वेरी क्विकली, बट इट्स ओके. सो इफ वी वांट टू डू इट, so over here vector 1, vector 2, and we call this my dot method, and my dot method is defined in this block. So this is the output. So note that the dot product is expected to return a scalar value. Let's try the same operation with np dot method. So 1 vector, 2 vector, directly call np dot a comma b. It will give us a comma b or b comma a, doesn't matter, because it has to it will do the element wise of multiplications, and then it will sum them up. So the answer is 24 in both the cases. Now, so above you will note that the result is 1D meshed our implementation. With dot method, with vectorization approach, we get 24, and with non-vectorization approach, we are also getting 24. Vectorization approach and non-vectorization approach both have the same results. Now we have to compare the time of these two approaches. For this, we call we provided a seed 1, np.random.seed assigns 1, np.random.rand. We created a very large array, 1 billion. reference to 8 elements array, very large array, 10 million elements, 10 million elements ka array. We have created these two 10 million elements array. We note the time, time dot time, capture the start time, time dot time, TIC start time, TOC end time. ठीक है, और इनके दरमियान between these two lines we perform the dot operation np dot a comma b. So this is the vectorization approach. And because the time will be in millisecond, this time method will return time in milliseconds.